All right, good morning, functions classes. This is the lesson that I taught on Wednesday. We went ahead and went over the back side of the worksheet that Mr. Temple worked on with you guys, the ancient puzzle. So, most of you, if not all of you, found out that the puzzle, the way that these are working together, is that 2 ends up being up here, a base, and then the 3 is the power, and then that 8 is what it equals. So that's how it works. And then it does it for every single one. So we have 3 to the third equals 27. Then we have 5 squared equals 25. And then we have 10 cubed equals 1,000. So we figured out that pretty simply. So we're going to use that. We're going to kind of see this. And one thing that I wanted to point out is how you read this. So we're going to look at this log base 5 of 25 is equal to 2. The way that we say that sentence is log base, oops, I went too far. Base 5 of 25 is equal to 2. So log base 5 of 25 is equal to 2. That's how you read it, and it's going to help you when we rewrite it and we convert from back and forth. The other thing that we want to remember is that a logarithm or a log equation, expression, whatever, is going to be equal to the exponent. It's going to be equal to a power. So we're going to talk a lot about that. So when we look at this, we are going to rewrite these to solve them. So we are going to do my log base 2, so base 2 of something is going to be equal to 16. So I just need to figure out what power of 2 is going to get me to 16. Well, 2 times 2, let's just use our fingers. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it has to be 2 to the 4th is equal to 16. So go ahead and hit pause and finish all of these on your own. And I'm curious to see what you get for F. Okay, so just to make sure you got that, so like if we go to C, we have some base, we don't know what the base is, raised to the second power is equal to 100. Well, it has to be 10 because 10 squared equals 100. Another thing that we could think of is the square root of 100 is equal to 10, which will get me 10 squared. So we can think about it different ways. E, I wanted to point out we have something to the 4th power equals 81. Well, that's obviously 3 to the 4th power is equal to 81. You're welcome for asking you about 1,000,000 times in the last unit what the 4th root of 81 was, which is 3. So you guys should be able to see that one pretty quickly. Now, F was a little bit tricky. So we have 100 is equal to 10. So we have to somehow take that base of 100 and make it smaller. Well, if we look back over here at C, we can totally see that we already kind of found it. So we know that 10 squared is equal to 100, and if we kind of think about that backwards, like I said, take the square root of 100 and that equals 10. So now we have to write that in an exponential. We can't leave it as a root, so we end up with 10 to the 1/2 is equal to 10. 100 to the 1/2 is equal to 10. So we have to be very careful with that, and we want to make sure that we have everything written in powers, written in exponents, because this is exponential and logarithm unit, and so we're going to see roots, we're going to see radicals, but we got to think about them or leave our answers in terms of exponents. All right, so now when we go on, let's see if I can get this to go. Now when we think of the inverse, so remember we were finding the inverse of y equals 3 to the x. So with inverses, we always switch the x and the y, and then we solve for y. We learned that last semester. So when we switch the x and the y, well, now I know how to solve for y. We know that logarithms equal an exponent. So we know that we're going to end up with something that equals y, and then we could just do log, my base is 3, and my answer is x. So log base 3 of x is equal to y. And we know that because it is the inverse of an exponential. So the inverse of y equals 3 to the x is log base 3 of x is equal to y. Okay, so we're going to use that idea of inverses. We're going to continue with that. Right now we're just going to talk about graphing the circle of logs and graphing exponentials. And when we talk about those things, we want to think about when we get to graphing of logarithms, how they're inverses of each other. And that will kind of help us with the picture and domain, range, and asymptotes and all that. All right, so we have the power of logs. So remember that, or the circle of logs. So we want to remember that it always equals a power, that we have our log base b, and our answers. So when we rewrite them in exponential, this is what it would look like. Make sure you get this in your notes. Okay, I want you to get this table in your notes, and we're going to go through it. So if I were to rewrite this log expression in exponential form, I would write my base first, so I know it's log base 3. I know my power is 2, and it's all going to equal 9. And then I'm going to kind of check my work. Oops. I check my work. 3 squared does equal 9. We are good. All right, so go ahead and finish the rest of the table, and then hit pause, and you should be able to check your answer. Okay, so now that we have the table figured out, we also want to talk about how logarithms can equal a negative number. So logarithms can equal a negative number, and that is fine because we can have negative powers, and we know how to deal with that. We know how to make them positive once they become a power, or once they become an exponent. So a student in class did ask about that, so I wanted to address it in the video, but remember that it is okay if a logarithm equals a negative because we know how to deal with it, obviously right here. Okay, so now that we've got that in our notes, we want to evaluate each logarithm. So when we look at these, I want to rewrite it. So I'm going to have, I don't know what it equals, I don't know what the power is, but I'm going to have 12 to some power is going to be equal to 12. So if we have that, then we know that 12 to some power is equal to 12. We know that it has to be 1. It needs to be this whole thing. I don't know why I wrote that there, not that. This whole thing doesn't equal 1. It equals 12 to the first power. So the power is equal to 1. So this whole thing equals 1. So go ahead and try the next one. Go ahead and hit pause and try it. So you should have gotten that the square root of 3 to some power is equal to the square root of 3. And again, that power must be 1. So when we talk about that, whenever we see a base and our answer, it must equal 1. Then when we look at this one, we have 3, our base is 3, to some power is going to be equal to 1. Well, the only way to get 3 raised to a power to equal 1 is to have your power equal 0. Because remember, we learned that 0, any base, any number taken to the 0 power is always 1, no matter what that number is. So then that's going to be true for this one right here. We're going to have 0.4 to some power is going to be equal to 1. Well, then that some power must be 0, because anything raised to the 0 power is going to be 1. So then those are our very first properties. Log base b of b must equal 1, and log base b of 1 is always going to be equal to 0. So make sure you hit pause and get those properties in your notes. Okay, this is today's lesson, and I will create another video for that.